Hello everyone and welcome to Module 7. In Module 7 we'll be talking about factorial ANOVA. Your chapter in SALKIND talks about two-way ANOVA. We'll talk about factorial ANOVA more broadly. Two-way ANOVA is a form of factorial ANOVA. So again, we'll start with the basic logic. The factorial ANOVA is similar to a one-way ANOVA, but it tests the effects of two or more independent variables, or what we call factors, on a continuous dependent variable. So same as the ANOVA in terms of the kind of dependent variable and having a categorical independent variable, but in this situation we have multiple independent variables. And so we have different ways of talking about factorial ANOVAs. So with two independent variables, each with two levels, we would conduct a 2 by 2 factorial ANOVA. With a 2-level independent variable plus a 3-level independent variable, so two independent variables, one with 2 levels and one with 3 levels, we would conduct a 2 by 3 factorial ANOVA. With a 2-level independent variable plus a 3-level independent variable plus another 3-level independent variable, so 3 independent variables, one with 2 levels and 2 each with 3 levels, we would conduct a 2 by 3 by 3 factorial ANOVA, and so on and so forth. I hope you get the sense of that after that. Factorial ANOVA is great because it allows us to examine the main effects of each independent variable and the interaction effects or effect of two or more independent variables on the dependent variable. So in essence, we're testing multiple hypotheses in a single test. So for those of you who are multitaskers like myself, this is more bang for your buck. So we're testing hypotheses, again, about main effects of each of our independent variables, as well as interaction effects. And I'll say more about interaction effects as we talk more about the logic of the factorial ANOVA. So again, the main effect is the effect of one independent variable averaged across the levels of the other independent variable or variables. So this main effect is the same thing that we were looking at in the one-way ANOVA, the effect of that single categorical variable on the dependent variable. And so in a factorial ANOVA, we may still need post hoc test, much like we did in the one-way ANOVA, to determine the location of the differences. If we only need post hoc tests if we have more than 2 levels of the independent variable. So for example, if one of our independent variables is gender and we only have male and female as the levels of that gender variable, and we find there is a significant effect of gender on our dependent variable, we wouldn't need to do post hoc tests because we would only have 2 levels. So if there's a difference there, if there's a statistically significant difference, we know by looking at the mean for male and the mean for female where that difference is, which is higher or lower. And then we have the interaction effect or effects. And this is the effect of one independent variable when the effect of one independent variable depends on the other independent variable. So the simple effects of one independent variable change across the levels of the other independent variable. So I'll say this a few more ways in just a second to hopefully help you make sense of this. This is a fairly complicated idea, but one I think that statistically and conceptually is really sexy. So when we have an interaction effect, we'll often need to do follow-up tests and examinations to determine the location of the differences or the pattern of the differences that we see. So an interaction is the combined effect of 2 or more variables on the dependent variable. In other words, differences between the levels of one factor change according to the levels of another or multiple factors. And so a significant interaction doesn't tell us where the differences are. We would have to do follow-up tests and graphical examination to determine the location of significant differences. We can do analysis of simple effects. We could conduct a series of one-way ANOVAs or t-tests, potentially splitting the file by the levels of the other variable. I'll show you again what this means by using a few examples to help you make sense of this. So perhaps one of the simplest ways to think about it is that interaction is the combined effect of 2 or more variables. And so we'll come back to that with some examples in just a second. Much like all statistical tests, the factorial ANOVA comes with its own set of assumptions. The first is that individual independent variable groups are independent of one another, same assumption as we had in the t-test and in the factorial ANOVA. Much like the t-test and the factorial ANOVA, the assumption is that our dependent variable is continuous, so an interval or ratio variable. that our dependent variables are normally distributed, and that we have homogeneity of variance and or equality of our group sizes. So very similar assumptions as we had in the t-test and the ANOVA. So let's break this down and apply this a little bit more. So let's imagine we have an intervention designed to increase sexual health knowledge among adolescents. For a variety of reasons, we might think that the intervention may work differently for boys than it does for girls. So we may ask the question, we may ask a series of questions. Is there a main effect of intervention conditions, so education versus control, on our follow-up sexual health knowledge scores? We can also ask, is there a main effect of gender on our follow-up or post-test sexual health knowledge scores? And then to ask the interaction question, we would say, does the intervention have a differential effect on sexual health knowledge scores for boys versus girls? And so we might say that a little bit differently when we're talking about interaction hypotheses. But in this situation, we could run a 2x2 factorial ANOVA. So we have two levels of our biological sex variable, male versus female, and two levels of our intervention condition, education versus control. And then our dependent variable is sexual health knowledge scores. And so that might be a scale score with a variety of different questions on there that we can assess knowledge about sexual health practices or various other aspects of sexual health. So another example that I will give you, and I've posted this entire paper on Campus Cruiser under the course content for this module. I think this is a clear example for me because it's my paper, but hopefully this will be a fairly clear example for you too, to understand a situation in which I conducted a factorial ANOVA, a series of factorial ANOVAs. And so my question in this, and this is a big area of my own research, is looking at sexual conflict. And so I define conflict as decisional uncertainty or conflicting feelings about condom use in particular. So this conflict scale is a 3-item scale, and you get a continuous measure of how conflicted you feel about condom use. And then I'm also interested in expectancies. And expectancies are the beliefs that you have about the effect of drugs or alcohol on your sexual behavior. So I think I'm a better lover, I'm more likely to say yes to sexual advances, I'm more vulnerable, I'm more likely to take risks. So people also fill out this scale and get a continuous score on sexual expectancies. And in this particular paper, we split people up into high conflict, low conflict, and high expectancies, low expectancies based on a median split. So everybody who scored above the median was high conflict. Everybody who scored below the median was low conflict, and the same for expectancies. So we turned a continuous variable into a categorical variable. And then ask the question, will conflict and expectancies interact in their effects on sex under the influence and sexual risk behavior under the influence? And so this is straight from the paper that you can look at. We hypothesize that individuals who are both conflicted about their behavior and strongly believe that substance use influences their behavior will engage in more of their sexual activity under the influence of substances and will report that more of their high-risk sexual activity, defined as unprotected sexual activity with a casual partner, occurs under the influence in comparison to the other groups. So people who are highly conflicted but have low expectancies, people who are not conflicted at all and have low expectancies, and people who are not conflicted at all and have high expectancies. In other words, we posit that expectancies will function more strongly among those who are highly conflicted. So again, the combination of these independent variables is what we're interested in. And for many of you who were thinking about moderation or interaction questions for your brief report assignment, I find it sometimes difficult to try and draw out how we look at these models and how we draw them out statistically. But this is how we draw a moderation or an interaction model. And so this is also from this publication. And so in this situation, we hypothesized that expectancies, sexual expectancies of drugs and alcohol, would have an effect on sex that people had under the influence, how much sex they had under the influence, and how much sexual risk they engaged in under the influence. But we thought that the role of conflict, this conflict variable, would influence the relationship between these two variables. So in other words, these two independent variables will interact to predict this dependent variable. And so these are also from the paper, so you can look at these and get a sense of how we laid out the ANOVA table. So this is an analysis of variance predicting sexual risk behavior under the influence of substances. We predicted two different outcomes. So one dependent variable is the percent of sexual acts that were under the influence. Another dependent variable is the percent of high-risk sexual acts that were under the influence. So this is condomless sex with a casual partner. And so these are two different sort of tables, basically. We put them into one so that we could have a really clear single table here. And so we have two different kinds of conflict. So if you think about if you were only looking at one kind of or one model and one outcome, you would essentially have just this part of the table. This has two different models and two different dependent variables. So this is basically four analyses that are presented in this single table. So really, if we're going to talk about just one of these, let's just focus on this top part of the table, this top left part of the table here. And so we're presenting here the results that we got using SPSS. And so we looked at a couple of different kinds of conflict. So this conflict is your motivation to engage in safer sex and your temptation to have sex without a condom. And so this model is theoretically informed. And we felt like people who say, I really want to have safe sex all the time, I'm really committed to doing it, but wow, I'm really tempted to have sex without a condom. Those are the people who are going to be experiencing conflict. And so we created a categorical variable here saying that people who are high in motivation to be safe and high in temptation to have sex without a condom would be the people who would be high in conflict. And so we controlled for age in the model because age was associated with the outcome. And so we have here our degrees of freedom and our F value and our eta squared for the full model. We have age in here as well, which didn't have much of an effect when we actually put it into the full model. Then we have the main effect here of conflict. And we see that there is not a significant main effect of conflict. But then we look here at expectancies, and we see that we do have a significant effect, a very significant effect of expectancies on the percent of sexual acts that were under the influence. So the more that you believe drugs and alcohol influence your behavior, the more sex under the influence you're having, which makes some sense. And we see this effect size over here. And so that's essentially the table that we use. I think one of the sexiest parts of interactions or moderation analyses are the graphs. I guess only sexy if you're into that sort of a thing, which I am. But so here, anytime you see these lines cross, you are often looking at what is potentially a significant interaction. And so what we see here, we could break this down, is that the orange lines are people who are low in conflict. So they're right here. The blue lines are people who are high in conflict. Over here we have the percent of acts that occurred under the influence. And then here we have people over here who are low in sexual expectancies and people here who are high in sexual expectancies. And so what we see is that if you're low in conflict, the expectancies really don't matter. You're scoring roughly the same, 60-ish% of your acts under the influence, 70% of your acts under the influence, regardless of whether you're high or low in expectancies. But if you're high in conflict, this blue line here, if you're high in conflict and high in expectancies, you're having 80-something% of your sexual acts, these are anal sex acts, under the influence of alcohol or drugs. And so if you are high in conflict, these expectancies really matter. So when we're looking at this outcome, we're interested in the combined effect of conflict and expectancies. And for our hypotheses, we were interested specifically in this group who are high in expectancies and high in conflict. And we felt like they probably would be having more of their sex under the influence and similarly more of their risky sex under the influence. We see a very similar pattern when we look at the percent of high-risk acts that occurred under the influence. This is one of our kinds of conflict. This is the one that's in this second model presented up here. So this is, I'm highly motivated to engage in safer sex, but I also really strongly believe in all the benefits of having sex without a condom. Like, it increases intimacy, it feels better, it demonstrates to my partner that I trust them. So this is a conceptual model, and you can look at this paper, which might help give you a sense of how we thought about interactions in this particular instance. And this is how we describe the results, which again, you can read in the paper as well. So in the first ANOVA, where the dependent variable was the percentage of acts that were under the influence of substances, the analysis revealed a significant main effect of expectancies, and we report the F value and the partial eta, such that higher sexual expectancies were associated with a higher percentage of acts under the influence. And then the important thing about interactions is that anytime you're talking about an interaction, you have to understand the main effects in the context of an interaction. So this main effect is qualified by a significant interaction between conflict and expectancy, and this is that F value. For those high in conflict, sexual behavior differed significantly between those with high versus low expectancies. But for those low in conflict, behavior was equivalent at both high and low levels of expectancy. That's what I just showed you in the graph in the previous slide. In other words, those who are high in conflict appeared to be the most sensitive to the effect of expectancies on the combination of sexual behavior and substance use. So again, this is looking at the combined effect of two different independent variables, conflict and expectancies. So hopefully between reading that article and talking about some of the conceptual issues in that article and some other questions, the idea of interaction will make sense to you. I find that this is a tough thing for students to understand. So certainly we can talk about this a little bit more, and I'll try and dig up some other readings perhaps that may explain it, and please let me know as you have questions or if there are ways in which I can explain it that would be helpful to you. So another question, another sort of set of research question examples. Let's follow with the examples that we've been using for t-test and one-way ANOVA. So when we talked about t-test, using the example from the AdHealth data, we asked, are there gender differences in contraceptive self-efficacy? So our null hypothesis was that there are no differences between males and females. Our non-directional research hypothesis is that there is a significant difference in contraceptive self-efficacy scores between males and females. And then when we did the one-way ANOVA, we asked if there are racial and ethnic differences in contraceptive self-efficacy. So again, our null hypothesis is that there are no differences between different racial and ethnic groups. And our research hypothesis is that there are significant differences in contraceptive self-efficacy between different racial and ethnic groups. And so with the factorial ANOVA, we can still ask those two main effect questions. Those are the main effects of gender and race and ethnicity. But we can also ask this interaction question. Do gender and race or ethnicity interact in their effects on contraceptive self-efficacy? So this would be a situation in which we might think that maybe we're looking at adolescent Black females, and we think that they're going to be different in some ways than some of the other groups. So white adolescent females, white adolescent boys, and we'll go through this example in just a second. So our null hypothesis would be that there's not a significant interaction effect of gender by race ethnicity. And our research hypothesis is that there is a significant interaction effect of gender by race ethnicity. And as you saw in the example that I gave from the article that I wrote, we did a directional hypothesis, and we were very specific about which particular group we thought would be different than the other groups and in what direction. So that would certainly be something that you could hypothesize depending on what your literature says, what your model is, and why you're conducting this particular analysis. So again, this is the same as the two-way ANOVA in many ways, but we have two or more independent variables. So we have gender and race ethnicity. So in this example that we're going to follow through this lecture, I've broken down race ethnicity a little bit more. So we're only looking at people who identify as white, Black, or Latino. If we were to include the other groups, I think we included Asian Pacific Islander, multiracial or other, and so that gives us 5 groups. And so we would be conducting a 2 by 5 analysis. In this particular situation, we could conduct a 2 by 3 factorial ANOVA. So we're looking at gender and race ethnicity individually as their main effects, and we're also looking at the interaction between them. So let's run through the 4-step process. That was a very long introduction to the logic of ANOVAs, but I do think the interaction is sort of a complex idea, and so I wanted to make sure we gave plenty of examples and talked through that a little bit. So let's run through the 4 steps of conducting and interpreting factorial ANOVAs, and then we'll do an example in SPSS. So as always, we'll state the null and alternative or research hypotheses, make sure we meet the test's assumptions, calculate the test statistic, and make a decision and interpret the results. So we'll state the null and alternative hypotheses, and let's talk about a 2 by 3 factorial ANOVA. And so in this situation, the nomenclature that we use and the way that we set this up becomes more complex. Many of you have been using the nomenclature as you turn in your assignments. That's fine. You can also present it just in words. And so in this situation, we would say there's not a significant difference in means between whatever is in our row, or there is a significant difference in means between whatever levels are in our row variable. And then the second main effect, if we're doing a 2 by 3, would be that there is not a significant difference in means between the 3 levels of the column variable. There is a significant, there is a significant, that not should not be there, difference in means between the 3 levels of the column variable. And then our interaction effects, so this gets really complicated as we're trying to use the muse here and this nomenclature. So we can say in words, row and column, whatever those variables are, do not interact in their effects on the dependent variable. And our alternative hypothesis, our research hypothesis, would be that row and column do significantly interact in their effects on the dependent variable. And so we'll again want to go through and make sure that we meet the assumptions and the test requirements. And so we see here that we have independent groups. We have the level of measurement as interval or ratio, so continuous on our dependent variable. And again, the dependent variable should be continuous to justify computations of the means. The populations are normally distributed on the dependent variable, and our population variances are equal, or our group sizes are roughly equal. So again, this homogeneity of variance assumption. We'll calculate the test statistic. Obviously, for this one, we're using SPSS. We're not going to go into the formulas for most of the tests that we're going to do after this. We'll skip the formulas. So one thing I want to note, your Salkind book, when it tells you the steps of conducting a factorial ANOVA, it tells you to put one variable in fixed and one variable in random, but doesn't give you any explanation as to why that is. I actually think the way that they do it is wrong. If you look at your Cronk text and the instructions that that gives you, that tells you to put both of the effects, both of your independent variables, into fixed effects. And so I would follow Cronk in what they tell you to do and putting both in fixed effects. And so I'll give you a little bit of a primer on what fixed and random means. Don't get too caught up in this. This is a fairly complex idea. Fixed effects are variables that we know and have sampled all the levels of that variable. So for example, gender. We know that if we have men and women in our sample, theoretically, I know there's a lot outside of the binary, but we know that we have sampled all the levels of that particular variable. Random effects are variables with levels that we think are a subset of the full possibility of levels. So maybe we're interested in college students and we've only examined freshmen and sophomores. And so we often make choices about fixed versus random effects based on our understanding of our variables. But honestly, fixed effects estimates are more powerful. SPSS gives us a lot more options within fixed effects. And so we often do fixed for all of our independent variables or factors, unless there's some conceptual reason to think of a factor as a random effect. So as you do your assignment, as we do the example today, we'll count both of these as fixed effects, both of our independent variables variables as fixed effects. Models that use all random effects are sometimes called type 2 ANOVAs or variance components models. Models with both fixed and random effects are called mixed models. So you sometimes may hear factorial mixed ANOVA or mixed factorial ANOVA. When you're doing SPSS, SPSS will also ask you if you want full factorial versus custom. Do full factorial for everything that we're doing here. The reason sometimes people do a custom model is that if you are putting in, let's say, 5 different independent variables, but you're only interested in the interaction between 2 or 3 of those, you want to limit the number of interaction terms that you're actually estimating and that you're looking at. And so you wouldn't necessarily want to know a 5-way interaction between all of your variables. That's a very challenging thing to try and interpret and wrap your head around. So typically we're going to want to limit the interaction terms that we have. Most people will say a 3-way interaction is about as much as you can try and think about interpreting. We also want to get effect size estimates and descriptives and mean plots, as well as tests of homogeneity variance. And so what that looks like when you're in SPSS, so you're doing this univariate model here, you've put both of your independent variables into the fixed effects, you've put your dependent variable into the dependent variable. You'll want to create profile plots. So you'll take each of your factors and put them on horizontal or separate lines. And so it doesn't matter, this is the example that is for the assignment for Module 7. It doesn't really matter which you put in which box here. So this is going to give you the variable that's on your horizontal axis, and this is the variable that you're going to have separate lines. So if you remember the example that I gave from my paper of expectancies and conflict, so we have high and low of each. And so it doesn't matter if you put expectancies on the bottom, or relationship status on the bottom, or HIV status as your separate line. So choose one that goes into each of these, hit add, and then continue. And then under options over here, it'll ask you what estimated marginal means that you want to see. And so I would say do all of them to get your overall means, your means for each of the groups, and your means, your simple means for the interactions. And so you'll see what those mean once you click those, and I'll show you what those mean for our example today. But this is exactly what you'll need to do for the factorial ANOVA assignment. You'll want to get descriptive statistics, your estimates of effect size, and homogeneity tests, and then you'll click continue. And then in step 4, you'll make the decision. You're going to look at your main effects F-tests and look at your p-values. You'll have to conduct post hoc tests to determine where the differences are, unless you have a 2-level independent variable, in which case the difference can only be in that one place, and so you don't need to conduct post hoc tests to figure out where those differences are. And then you'll look at your interaction F-test, or tests if you're looking at multiple interactions, and look at those p-values. And if there are significant interactions, or if there is a significant interaction, you'll only consider the main effects in the context of the interaction effect or effects. So you'll want to graph your simple means, that's the plots that I just showed you in the last slide. You might want to conduct tests of simple means to determine the exact location of differences. And as always, you'll want to consider the clinical or practical importance or significance. So just because something is statistically significant doesn't mean that it's important. And so you always have to think about the magnitude of differences, the location of differences, and determine if that's actually relevant for clinical practice, educational practice, etc. So let's run through a full example in SPSS. So let's come back to this question that I posed at the beginning, which is following from the examples that we did in the t-test module and in the one-way ANOVA module. So in the factorial ANOVA, we still have these same 2 main effect questions. Are there gender differences? Are there racial and ethnic differences? But now we're adding this, do gender and race ethnicity interact in their effects on contraceptive self-efficacy? And so there's not a significant interaction effect, and there is a significant interaction effect, are our hypotheses. In this situation, we're conducting a 2 by 3 factorial ANOVA, and our independent variables are gender and race and ethnicity, and we're also looking at the interaction between gender and race and ethnicity. So again, coming back to this model here, and so essentially we're comparing here 6 groups. So when we have a 2 by 3, we'll have 6 groups, and you can see how these groups get exponentially larger the more variables and levels that you add. So in here, we're essentially comparing 6 groups in our analysis. So let's check from AdHealth that our assumptions are met. So we have independent observations, race and ethnicity are independent, the levels are independent of one another, male and female are independent of one another. We have a continuous dependent variable plus our categorical independent variables. We have some differences in our group size, and we'll check again the equality of variance in the analyses under our options. We did this for both of the tests before, and we'll also check the distribution of the dependent variables. So again, same answer here, meh. We have a very large sample in the AdHealth data, so we won't worry much about most of these assumptions. So for factorial ANOVA, we often say that it's fairly robust to violations of many of these assumptions, depending on how much you're violating those assumptions. That may vary. So people talk about differences in group sizes, and so if you're comparing like 1,000 people to 20 people, that's a problem. So if your group sizes are roughly equivalent, you should be okay, or not wildly off, you should be okay. But when in doubt, you should do a little bit of research and figure out if the comparisons that you're making are legitimate. So this is the syntax for this. So this is going through the click buttons and putting contraceptive self-efficacy in by our race and our gender variable here. And so I did ask SPSS to give me a post hoc test and to do the Gabriel test, because we see that we do have a significant difference in equality of variances. So I asked it to give me the Gabriel post hoc test, and we'll only need the post hoc test for race and ethnicity variable. Gender, we only have 2 levels, so if there is a main effect of gender, we'll be able to look at the means and tell exactly where that difference is. And so I asked it to give me the means. For all of these, I asked it to give me eta squared, the homogeneity tests and descriptives, and then I told it the design, so the main effects of each plus the interaction term here. And so again, we see that there is an issue with our equality of variances. We're going to go ahead and move forward because we have a large sample and because we're asking for post hoc analyses that account for that inequality of variance. So what we see here is our grand mean on contraceptive self-efficacy. We see our mean according to the race variable. And again, as I mentioned in the beginning, what this is giving us is the main effect of one variable at the average level of the other variable. So these are going to be a little bit different than what we would see if we only had the race variable in the model, or only have the gender variable in the model. And so we see these basic means here, and then we see these simple means that we get. So this is crossing the variable. So this is the same thing that we looked at in that little table that I showed you. So we have the mean and standard error in this situation for white males, white females, Black or African American males, Black or African American females, Latino males, Latina females. And so essentially what the ANOVA is doing is allowing us to compare all 6 of these groups, the factorial ANOVA. So here are the results that we get. So here we're basically looking at the main effects. So this is the race and ethnicity variable, this is biological sex, and this is the interaction term. So these are the 3 variables that we're interested in looking at. And so we can see over here, we have our F values for each of these, and we have our P values for each of these, and then we have our partial eta squared for each of these. And so what we see is we have a significant main effect of race and ethnicity, a significant main effect of gender, but those variables do not interact. There's not a significant interaction. And so for the race ethnicity variable, because we have more than one level of that variable, we ran a post hoc test. So this is our Gabriel post hoc test down here, and we can look and see where the differences are. So if we look at this pattern of differences, whites are significantly from Latinos, Blacks are significantly different from Latinos, and so we know, of course, that Latinos are significantly different from both groups. And so when we're talking about this, we write this up, which is a very similar write-up as you'll do in your assignment. So we conducted a 2x3 factorial ANOVA with biological sex, male and female, and race ethnicity, white, Black, Latino as independent variables, and contraceptive self-efficacy as the dependent variable. There were significant main effects of biological sex, and we have the F information there, and race ethnicity, but there was not a significant interaction between the two. Men scored significantly higher than women on contraceptive self-efficacy, indicating significantly lower levels of contraceptive self-efficacy among men. If we remember, that variable is flipped, right? So higher levels on that variable indicate lower contraceptive self-efficacy. Gabriel post-hoc test indicated that Latinos scored significantly higher than whites and Blacks on contraceptive self-efficacy, and we have the means in there, indicating significantly lower levels of contraceptive self-efficacy among Latinos compared to whites and Blacks. So as always, we have to consider here the magnitude of these differences and the importance of these differences. So there is a statistically significant difference here. Is 5.7 versus 4.9 important to us? Is that, like, should we say, like, oh my God, there are gender differences in contraceptive self-efficacy and we have to help men feel better? Is that difference really all that important or meaningful? Maybe if we look at the range of the scale, that's actually a big jump, considering that the scale is only has a small range. That might be something that we are interested in, but we have to think about that. So are these differences really important to us, even if they are significant? And so as you interpret results for your assignments, those are questions that I want you to answer. And obviously those are in your own opinion, those are based on what you know of the literature, based on what you think, but I want you to think through interpreting the clinical or practical significance or importance as well as the statistical significance. So with the Module 7 assignment, as always, you'll download the data set and answer the research question proposed in the assignment, write up your results paragraph, and make sure everything is in APA format. If you have questions or thoughts, post those under the general discussion forum. We can talk about the interaction in particular more in a Google Hangout at some point. I know this is a tough concept, so hopefully between the reading, the lecture, and reading the additional article, that will help you understand the concept of interaction. Thanks.